You're listening to Spill the Sea with Ashwati Ramesh.
Amit, hi, so good to see you again.
Likewise, happy to see you too, and in a new role, doing new things. So
Thanks.
yeah, really excited about this.
No, excited to have you here. Thank you for coming on to the podcast. Really excited to kind of get into the details with you about the work that Hastin does.
Yeah.
But before that, as always, I would like to thank Copper and Cloves, which is a plant-based cafe. They've let us use their lovely studio for this and our previous episodes as well. Cool. So, do you want to tell us a little bit about what Hastin Energy does?
Yeah. So Hastin, the word was derived from the word Hasti. In Sanskrit, it means strong and powerful, elephant-like, and that is what our motto is. Like we want our batteries to represent a strong set of batteries, reliable, tough, rugged set of batteries, and particularly given the industries that we are targeting, unmanned space and electric commercial vehicles.
Yeah.
So over here, the dependability on the battery is really high. Either ways in every industry, but over here, you won't have room for error, and that is what we represent at Hastin Energy, and that's how the name derived.
Right.
And we started out in December of 2020. We just turned 4 last month, and we have had a roller coaster ride. Really lot of great learnings, and we have commercialized our first set of product, and that is where we are now.
Amazing.
Yeah.
Good to hear. So, I mean, before we get into your product line and all of the specifics, tell us about your journey before founding Hastin.
Well, I was kind of an oddball still, I would say, within the whole energy industry.
Yeah.
But I started off pursuing my chartered accountancy, and right when I was in the middle of it, a family friend of mine, she was looking to set up a lithium-ion cell manufacturing plant along with a Taiwanese partnership.
Right.
This was back in 2018, mid of 2018, and since she knew me from childhood, she's like, "Hey, why don't you help me out set up this whole thing?"
Yeah.
I'm like, okay, either ways, I had to get work experience as part of my chartered accounting thing, and she was like, giving me the role of finance and ops. I'm like, okay, fine, that's a good start.
Yeah.
And seeing a company right from the early stage, and that is how I started in mid of 2018. And back then it was kind of very, very early days of climate tech in India, and
Yeah.
particularly for batteries. Everything was being imported from China. Even today, largely a lot of things are imported from China.
Yeah. We'll
But,
come back to that.
Yeah. So, but back then it was like really, really high. So that is where she had seen an opportunity, and she said, let's just start. And she had good contacts from Taiwan who were also keen on the whole India movement happening, and that's how we started. But year down the line, we understood how difficult it is to do anything in the hardware technology space, and moreover manufacturing of cells. And after running out of all our savings, she said, okay, fine, I think I'm going to take a break from this and figure out what to exactly do. And lucky for me, that's where my parents were like, why don't you experiment, why don't you see, because you're still young. I was like 22 then, and why don't you experiment and see what could happen. So we would get our batteries made from a contract manufacturer, put our branding in the previous company's name. It was Adaptive Energy Systems.
Right.
Right over here in Indranagar.
Okay.
So yeah, and our earliest customers were Swiggy, Zomato, National Aerospace Labs. The government was really pushing for food delivery drones, and everybody were trying to make it, and quite a few companies came out, and that is where we had. So we always had a clear thought that, okay, we are going to make batteries for drones. That is where we're going to start and slowly go up the ladder.
Right.
Because we had already burnt our hands trying to put up a cell manufacturing thing, though it was with a joint venture
Yeah.
partner. So we had a learning, so we thought, let's go to the drawing board and kind of do the batteries first,
Yeah.
and then kind of walk back and scale down to the cell, because it takes a lot of effort, lot of team, lot of capex, right?
Yeah.
So I said, okay, fine, and that is where we started. And back in those days, there were no rules around drones flying. It was very, very nascent stage, and only in 2022 the drone regulations came into place and it kind of got formulated.
Yeah.
So that is where we started, and right from the beginning of our careers, myself and Mainak, and also from the early days of Hastin, we have remained focused on catering to the unmanned systems. It could be ground mobility or aerial mobility, aerial vehicles or ground vehicles. And after only 2020, we started focusing also in the commercial vehicle space.
Got it.
Yeah, that's the start.
Amazing. And what about Mainak? How did you guys meet and decide to do this?
Well, Mainak, my cousin was working with Aether, and he had just got out of Aether, and he had a non-compete and all of that.
Right.
So he was just basically killing time for a year, and that is when upcoming they're now big. One of the performance electric scooter startups, they approached him for mentorship and all. When he was trying to get to know the team, he had come across Mainak,
Right.
and I was trying to put up a battery company, and Mainak and his team were looking to build an electric scooter. They're like, there's some synergy, why don't you guys work out? And that is how it started, and that is how I got to know Mainak. And few months down the line, it didn't work out for him in that company and for two others, so he decided to move on from there.
Right.
And like, okay, fine, you are building battery, and I wanted an in-house tech guy because I was still outsourcing for the batteries, right? So like, yeah, I either ways needed a tech guy in-house. So that is how it started, and he became part of the previous company as an employee initially,
Right.
where even I was an employee, and then we started working together. About a year down the line, when there were a lot of changes in the previous company, when they decided to kind of pretty much shut down the operations, that is when we were like, okay, fine, we are either ways doing everything, so why not just start our own? And
Yeah.
that is when we started in December 2020. We're like, okay, fine, we know each other for a year now, and we know more than a year, and then how we work and everything. So between mid of 2019 until end of December, we had got a good 18 months of period to work with each other, and COVID played a big role actually.
Right.
So he was a student. His parents used to stay back in Kolkata, and during COVID, he stayed with me along with my parents. So like,
Okay.
got to know him
That's
a
passed
lot.
the test then.
Yeah, so we got to know each other really well, and it was like 4 months of lockdown, 3-4 months of lockdown. So
Yeah.
if you were to get bored of a person during that course, probably it would not have been a logical reason to go ahead with the company. But yeah, we know, like, I think you do your thing, I'll do my thing, and then we can kind of grow this. So he's the complete tech brain behind company, and I'm the non-tech guy. So yeah, that is how I met Mainak, and Hastin happened.
Awesome.
Yeah.
Thanks for sharing that. That was nice to know. So, Amit, obviously the lithium ion market has grown over the last decade. What do you think are some of the significant changes in India, especially?
In India, particularly, thanks to a lot of government initiatives, a lot of battery manufacturing is now happening within India. Though we are still dependent on importing lithium-ion cells, the chips for the battery management system, the IC chips.
Right.
But a lot of what a battery needs, of course, apart from the cells, is fortunately being manufactured over here in India. The complete battery, the design of the BMS, a lot of battery management system companies that have come out of India and are really good, and are also probably competing. I can say that we are good right now in terms of competing with the Chinese products in terms of price, and still deliver a better quality product.
Right.
Is something that India is doing right now, particularly in the electric two-wheeler and three-wheeler market. We have nailed it, I could say. So that is a very big positive step. Whereas where we are lagging in some ways is to, as an industry, as a country, to put up lithium-ion cell manufacturing plants. Though
Yeah.
it is happening, but it's mostly from the big guys who have been kind of in the monopoly position for decades together.
Right.
Fortunately or unfortunately, it's again with Chinese partnerships. Not that it's a bad thing, but for such hardware technologies, we need to be more resilient, kind of self-dependent rather than depending on technologies outside.
Yeah.
Let's say if it was 5 years ago, okay, fine, it's early in the days, we could have low volumes, everything's just starting. Those days, yes, but we are still looking out for opportunities when there are quite a few good, technically or commercially viable technologies that are coming out of India. So we just need a little more of those big guys to come, partner with startup, kind of handhold them and take the technology to a bigger scale.
Right.
Yeah.
And what do you think is one of the major roadblocks that is preventing, the cell manufacturing bit from picking up here?
One is, of course, the materials what we have to procure, right? So if I were to draw a comparison, so to say, the oil that we are burning in IC vehicles, it's coming out of the Middle East. A good majority of it, of course, now post Russia, Ukraine, a lot of it is also coming from Russia, and India signed deals with Guyana, for procurement. But nevertheless, a lot of it comes from Middle East. So how we are dependent on the Middle East for oil, I would say that we are dependent on China for refined battery materials. If you spend let's say a few weeks in China, you will find a dozen or more vendors who are in a position to set up a cell manufacturing line for you and probably give you a very very basic material contract as well. They'll just show you set up the whole thing and you have to just run the ops. But
Right.
that won't take us far because we are again dependent on the whole technology, the materials, and every process bit part with the third party vendor from China.
Right.
So we are dependent on that. So I feel that that is a major roadblock. And India had been exploring mining opportunities in Central African countries and South American countries. I think I've been reading about it for the past half a decade, but Videsh Minerals something, so right, but that hasn't materialized for India. Though we can get Indian material companies like chemical companies, or material companies, or even Japanese companies to come set up in India for these
But they
things.
still own the IP.
Yeah, they still own their IP. That is one. And when we don't have mining rights to get the materials out, a lot of it we're like kind of stuck in between. We have a lot of ambition to go electric, and the government is also pushing to an extent. But if your raw material is completely owned by another country,
Yeah.
of course it's a globalized economy. We are entirely dependent on each other. But at the same time, we need to build these supply chains by ourselves right from the start. So over there, that's one thing that I feel is a major roadblock. And another thing could be that unlike the developed economies, a lot of investments do not happen a lot into the capex heavy industries.
Yeah.
So even in the VC world, so to say. So they would rather be okay for a lot of OPEX where you develop the technology. But then when it comes to commercialization where it's a lot of CapEx, I won't say it's the same now. It is changing, but not at the pace where probably it should happen.
Sure. We definitely do need more patient capital for
Yeah.
such
Yeah.
sectors.
So I understand their reservations, right? Like
Yeah.
it's
Their business model is
yeah. I
doesn't
mean,
make sense for their business
yeah,
model.
it's something a bank or a government should initially start off with. The PLI is encouraging, but
Or someone with a much longer timeline.
yes, so probably national funds and things like that. But when they do come at a very late stage, it's already too late for a lot of startups to have survived till then.
Sure.
So yeah, that's where I see there are a few roadblocks. But overall, in general, I'm quite optimistic about where we are moving and the different approaches the government has also taken.
Yeah.
But at the same time, there are few things like every other day the ministry tells that they're going to bet on a new technology. For a month, whole long month, it would be electric, and all of a sudden they're like, hey, hydrogen, we're going to do hydrogen. So probably there needs to be more consistency and a long-term vision in terms of which technology that we want to bet, and also take cues from the European Union and the West as to what has really worked, and particularly from a major economy like China and what technology has worked, and kind of push that forward rather than kind of spreading your bets across different industries.
Right.
That's one thing that I really feel like could give that push to an industry as compared to spreading too thin on a lot of industries. Like when you see the heavy commercial vehicle, government is still pushing for CNG and LPG, LNG sort of a thing. I'm like, why? Electric could be a way more efficient mode of transport. I understand the grid needs to develop. There are so many challenges, I'm not denying, but it is where probably 4 years 5 years ago, where the electric industry was, everybody would complain, where are the charging stations? And then the charging station guys would be, where are the vehicles? So it's a chicken and egg problem. So at the same time, we honestly need to probably have a proper think tank to kind of bet on a one or two
decision.
Yes, that's definitely needed. So roadblocks, if you were to say, these are some of the major ones that I would see.
And what about the batteries themselves? I know we've discussed this before, but if you would like to elaborate on some of those challenges.
Well, a lot of things, like I said, are improving. So let's say something like range anxiety, which was a major problem before, is now no longer a problem, because a lot of state-owned electricity supply companies, discoms, so to say, and private players are setting up charging stations. So in terms of adoption, right? And in terms of battery, there was initial issues around thermal runaways, the fires, but that is already improving, in my opinion, because companies are developing engineering batteries specific to Indian needs. Early in the days, we had got batteries from across, which were not specifically designed for the domestic needs of India and the use cases that are generally needed in India. So in a environment like this, in a climatic condition like this, you can't have a battery that's designed for a Nordic country to operate in the same way.
Absolutely.
Right? So those are some of the roadblocks. But thermal runaway is, I don't think it's a problem as such right now. Though we as a company are engineering batteries on that. But things are improving, is what I mean to say, right? Companies are understanding the use cases of batteries. It's no longer a single battery that fits all the application. Batteries are now being developed specific to industry, specific to applications, and it's no longer one battery engineer that's going to go into 10 different vehicles and get abused. So that's no longer the case, and a lot of focus is being given to thermal management, battery electronics. Before, it was just slap one BMS onto slap any BMS onto a battery and then just send it out. That is how it was probably 4-5 years ago. Very little, and also it kind of had become a cottage industry, so to say, where every random guy was doing spot welding batteries. But that is no longer the case. There is a lot more focus that has gone into batteries, choosing the right cell, choosing the right manufacturing method, bonding the cells, and choosing the right kind of battery management system, the communications of it, the overall integration of that with the vehicles. All of that has overall generally improved. So if I were to say the roadblocks within the battery industry, I don't think so. In my opinion, there are many. So few are there, but not anything that can be
not unmanageable.
Yes.
Okay.
Yeah. Or in other ways, I'm quite bullish about how things are moving in the battery industry. So it could also be that, but I don't see major roadblocks as such from a battery engineering perspective. We have enough talent within India who got exposed to this in the past 5 years. People who have come back from abroad, that's really an add-on for a lot of startups. Have kind of people who have come back from abroad, having worked in the battery industry, and they have their own startups now. That's also helping a lot for an industry to set a standard, a benchmark of what a battery should be. So those are some of the things that have really helped us. So I wouldn't be pessimistic about battery engineering as such.
Got it. And since you guys focus on thermal management, can you, for our listeners, elaborate a little on why that's important for the industry?
Yeah, so one main thing is first is the thermal runaway, the fire as such. Second thing is the performance, and the third thing would be the longevity. And the fourth thing probably would be the charge discharge speed, right? So everybody wants a faster charging rate. And when this happens, there is a lot of heat that gets built up. So, these are the four main reasons. And to start off with thermal runaway, nobody wants a fire, be it an IC engine or a battery one. And a lot of middle-aged folks still have the fear around, accepting a battery vehicle. That has changed to a great extent, but some might still have that. But when you add a layer of, specifically engineered batteries with a lot of emphasis on the thermal part of it, that is the first issue that gets solved.
Right.
Second is the performance. So imagine, let's say, a 40 kilowatt battery giving the same output in peaks. Sorry to get slightly technical.
No, that's fine. That's
to give peaks of something what a 60 kilowatt battery could, just because it has better thermal management,
Right.
or what a 50 kilowatt battery could in a 40 kilowatt. So you need not put that extra capacity, which will otherwise pretty much lay as a dead weight, though it can extend your range and whatnot. But that also comes at a cost. That also comes at a cost in terms of the price, in terms of the weight that it adds, and what is the range ultimately that you could get. So many different permutation combinations, right? So when it is managed better, the thermals, you can extract more juice out of the same battery pack.
got it.
That is one.
Yeah.
And when you manage your thermals better and let the battery perform in its ambient or in its sweet spot, so to say, you can expect reduced abuse in the battery, and that will naturally result in better life cycle, sustained charge discharge.
Right.
There are a lot of factors that will determine in terms of what the cell, the kind of the cell that we use, how it is engineered, for what application it is engineered, all of those factors. But thermal management is key for these three factors, and also the fourth one, the charge rate. So
Right.
if somebody wants to tap into 15 minutes, 20 minutes, thermal management is a key factor. And everybody wants fast charging. Nobody wants to sit waiting around for 2 hours, 3 hours. Probably that's still a thing with commercial vehicles where the drivers take a fairly longer breaks, where they can afford to have that time and you have more room to charge. But at the end of the day, quicker charging is better even for those applications, because let's say when these vehicles get autonomous, that's not going to happen anytime soon in India, but let's say in a controlled environment at least.
Yeah.
Quicker charging rates are good for everyone, because that leads to lower idle time for vehicles, for operators and everyone.
Yeah,
So
yeah.
the more it stands, the vehicle, the less it earns, right? And that again comes back to how fast you can charge the batteries. So this is why we close the loop, right?
Right.
Better thermals means better safety in terms of fire, better charge discharge cycles, longer life cycle,
Yeah.
and also quicker charging. Yeah.
Perfect. That was very well put. Maybe to move on to advanced battery systems, could you elaborate a little bit on that and why that's also important?
Well, if I were to say one piece does not fit all, if I'm telling about advanced battery systems, it could also be about experimenting with a new cell technology. Sodium-ion is a thing that's coming up everywhere. Graphene batteries, solid-state cells.
Yeah.
Graphene, I don't think it will make way into commercial vehicles anytime soon. Same case with solid-state. I think we are at least a quarter of a decade away in India, at least, or even across the world for that matter, because the price is quite high. So when we are looking at something like $90 or $100 per kilowatt capacity in the battery, people will want it cheaper and cheaper. They'll want it like something like what you would pay for a lead acid, right?
Yeah.
So that is how people expect, that is how markets expect. But when you add that extra layer of using advanced cell chemistries, it adds a lot of price. And also, in India, price sensitive economy, LFP batteries have worked really well. Not even NMC, NCA batteries,
Right.
because unlike how it has worked for somebody like Tesla, even Tesla is moving towards LFP in chemistry supplied by CATL. So I would say in terms of advanced battery systems, niche applications are the first way for it,
Right.
than going into larger applications. We wouldn't touch anywhere in the two-wheeler, three-wheeler market.
Okay.
because it's highly price sensitive, and
Yeah.
trying to experiment something new, unless a startup is absorbing all the costs for, let's say, 1,000-2,000 units, which is a very tall ask.
Right.
I don't think advanced battery systems will make way into these segments anytime soon.
Mm-hmm.
And in terms of engineering it, let's say heavy commercial vehicles. To let you know, there was a recent deal, I believe it was of $6 billion, and
Okay.
mammoth size excavators have gone electric. This happened in a mining field in Australia. So
Right.
the mining operations are so huge that the mining company itself has partnered with a German heavy machinery manufacturer,
Mm.
and vehicles the size of 4-story buildings have gone electric, not hydrogen. So
Right.
so in terms of advanced battery technology, I see it making way in those places. I see government entities playing a major role over there, but unfortunately that's still not happening in my opinion. So
Mm-hmm.
something like BHEL, which makes a lot of earth movers and heavy machinery for mining operations, and also exports it. That is
Yeah.
where I see advanced battery systems kind of having a major role, because over
Mm.
there the volume is less, but the capacity and the size of the battery is quite high, and the room for innovation for startups over there is a lot. That is where I see startups like us kind of adding value.
Right.
And for instance, people are using immersion cooled battery systems in two-wheelers and three-wheelers. I honestly think that it's not a market for it, because take Ether for example. They
Mm-hmm.
have a 4.5 kilowatt battery, if I'm not wrong, and it's so well engineered, thermally so well managed, that you don't need an extra layer of immersion cooling on that, because it just simply adds cost
Right.
and the complexity of it also. So why not just take the leader's cue, and for a 4 or 5 kilowatt battery, we honestly don't need. And uh, it's not something that a consumer will like to absorb,
Mm-hmm.
unless it's a performance electric scooter, something that will do 150 kmph, and that's a very niche market.
Right.
Whereas the majority of the market for immersion cooled, if you want to put advanced battery in the immersion cooling space,
Mm.
that I don't see any value addition in the two-wheeler, three-wheeler space, apart from one factor, that is the fire.
Right.
Right, that either ways companies are doing well without having that. Of course, they have different thermal interface materials, like phase changing materials within the battery,
Yeah.
that is doing the job well. So why add that cost, weight, and the complexity of engineering in a segment like electric two-wheeler or an electric three-wheeler? Yes, one thing is that the mass opportunity that there is, it still does not make sense.
Yeah.
That's one pessimistic view, if you were to call it.
Right.
Yeah.
So I guess this will be a good time then to get into Hastin's product line. What are your offerings looking like?
Yeah, so we typically operate in two segments. One we are still developing for, and one we have commercialized for. One is the unmanned space, which is unmanned aerial vehicles and unmanned ground vehicles. This industry we've been focusing for the good past half a decade. So before even we started this company, it's a very niche market.
Yeah.
It has started off slow, but things have really picked up now. And in the past 2 years, things have really picked up, particularly in the unmanned aerial vehicle space.
Right.
And the government has come up with a good set of rules, and it has given a start, thanks to folks who are brought from the private industry and kind of pushed around regulations, and there are good industry bodies that have kind of pushed the whole movement within the unmanned aerial vehicle space. So we primarily cater to the UAV, UGV space, and this is through our Astra Smart battery, which is a Bureau of Indian Standard certified battery.
Okay.
So batteries that have to go into the UAVs have to be BIS certified as per the norm,
Right.
and we got our certifications done through last year.
Okay.
And this is a step towards our batteries going into drones that will further go for certification with Directorate General of Civil Aviation. So
Right.
without that, no drone can fly in India. So though hobbyists do fly here and there, but for a commercial operations,
Yeah.
this cannot happen without proper certifications. So we took about a good 1.5 years to develop this. We have our in-house developed battery management system, which can monitor currents up to 240 amps, and currently up to 25 volts of capacity. And where we kind of take pride is how compact the design of these BMS systems are. Typically, what if you were to import a BMS for this spec, it would easily sit like a diary notebook of sort, a good 12 by 20 centimeter and at least about 2 to 3 centimeter thick profile.
Right.
But we have packed it in about 5 by 6 centimeter and in 40 grams of packet, whereas the what is traditionally available would be somewhere close to 700 750 grams. So
Right.
because every 10 grams in the drone industry kind of matters to them,
Sure.
and we have to be very very mindful about the whole weight of the overall packaging of the battery system as such. And this we have made it very compact and very very reliable even in terms of high current, high temperatures. And this we have also paired it with the flight controls of the drones, the popular ones, flight control systems of the popular ones. And also, in the very worst eventuality, if like let's say a drone crashes, usually when a drone crashes the blame is on the battery because power failure. That's the easiest thing to do, something like what you would do engine failure in an aeroplane, right? And the blame is usually on the battery. So what we did was we put up a small black box like feature wherein as long as they can extract a chip that is out there, they'll get the complete information on the what has happened till the last second on the electrical front. So that way they can kind of backtrack and diagnose what
Where
really
exactly it went wrong.
Yeah. So that is the value addition we have done, and all of this while competing with the Chinese counterparts, which still majorly rule the Indian drone battery market space. We have done that in the footprint and the weight, similar or lesser in application, and also we are competing with them in the price as well. So this is what Hastin is able to offer with Astra Smart Battery, and that was possible mainly because of in-house design and development of the battery management system. This again is paired with Astra Utility, which is like a communication tool, and we brought this into picture because government is the biggest driver for demand at this point in time. So draw contrasts, to draw similarities. Where the electric two-wheeler space was, say, 5 years ago, which was majorly subsidy driven, that is where the agri-drone industry is as of today. And agri-drone industry is the biggest drone market in India as of now. And the recent tender was for about 2,500 drones floated by IFCO. And that has driven the kind of the market. And now the whole industry is anticipating a scheme directly overlooked by PMO. It's called Drone Didi scheme, wherein the government is looking to empower women at a panchayat level to have drones, provide the services of spraying, could be fertilizers, herbicides, pesticides, or a lot of other things, and earn an income. So this is being subsidized by the government, procured by the government, and then being passed on at a municipality level, panchayat level, for women to operate these. So the problem comes when you have to educate them how to manage a battery, which is a crucial factor. But a lot of them are not per se equipped to do that, because they have been taught, they have been trained how to operate drones, whereas batteries make a significant chunk in terms of the inventory or the assets for a drone company. When let's say a company is contracted to deploy and operate, it could run into like a good $500,000 for each company, and this is on a rolling basis, on a year on year, on an 18 months basis. So when the batteries are not maintained in an appropriate way, like as per the data sheets, the batteries tend to have a lesser life cycle, which means the farmer can have, or the operator can have, a fewer life cycle, and they'll have to again shell out on the capex. Be it the operating company, or the end cost does get passed on either to the government or the farmer on an acre basis, right? So what we have done is we have tried to simplify this process for the drone company. So through Astra Utility, the user can, at the click of a button on a screen, the essential information of the battery is immediately sent to the field operator or the person who's managing the fleet of drones. That way they can guide the end user what to do with the battery, because it's a seasonal business, and when they are not using the battery, say for 4 or 5 months of time, it has to be stored in a certain way.
Yeah.
4 or 5 months is lot, so they say about 2 months or 3 months of time, the batteries have to be stored in a certain way. So, and typically this does not happen. So when they come back from the off season, when they see a lot of batteries are imbalanced, and when the batteries are imbalanced, when they're putting batteries in pairs to fly a drone, there are crashes, there are so many issues that will pop up.
Yeah.
And because of which the drone companies are kind of forced to buy a new set of batteries more frequently. Though companies might have like, well, that's good for battery companies when somebody's buying more batteries, but overall that's not a good thing. So we have tried and developed a product where this problem is reduced all with a simple click of a button. So we have not added the complexity of a SIM card to remotely monitor this, because that's an additional cost layer. That's at least about 1,000 rupees a year per battery, which is not something everybody can absorb. Again, we as a company cannot absorb that. It will eventually be spread out. And let's say each drone is having at least about 6 to 8 batteries. That's about 6 to 8,000 rupees of additional cost per year.
Right.
And this again recurring. And we didn't want to go down that route. And we also did not want to add a Bluetooth, because it might interfere with the drone communications, and so many different ways it can kind of create roadblocks.
Right.
So we have kept it simple, wherein our batteries can be plugged into any smartphone device, and with a click of a button, all the information goes to the drone operator. I mean, like the fleet manager or somebody who's managing the fleet. So this way, instead of, let's say, buying a drone every year, we are extending the life cycle by at least about 120 life cycles. And also, if I were to give you a timeline, it will last more than one whole agri season. I mean, like one whole year and more, about say 30% more. So that reduces the time in which they have to procure new batteries. And now that we have built this, we have a historical record of which battery has been abused to what extent. And we as a company at the end of the cycle can take a call which battery is good for recycling and which battery is good for repurposing. We are exploring opportunities in this, wherein companies that are either procuring this at a fairly lower price than new batteries and repurposing it could be for a social cause, as a CSR thing, or it could be for low current applications. That is where this whole thing helps.
Got it. And what about your immersion cooling technology?
Yeah, immersion cooling, we are primarily focusing it for the 1 and 1.5 ton electric commercial vehicle, initially to start off with intracity operations, and we'll be showcasing it on a electric, sort of a pickup truck sort of a thing. And this is to showcase that it's a 30 kilowatt system that we'll be showcasing. And this is for startups, it's quite difficult to partner with OEMs right from the get-go and do this. So we're hoping that this kind of opens doors for conversations with OEMs. And this is a modular system, initially targeted towards 1.5 ton vehicles, and focusing all the way up to something like electric dump trucks and electric bus, which are doing about 250-300 kilometers of travel. So that is where we are typically focusing. A lot of these battery systems are still being imported, particularly at a bus level, or there is a monopoly along with a Chinese partnership by Indian companies. So we want to break that over the next 2 to 3 years. So for the next, I would say until 2026, for us, it's Astra smart batteries, typically for the unmanned vehicle system. And by 2026, we'll start moving more towards the electric commercial vehicles.
Got it.
Yeah, these are the two markets that we operate in.
Understood. So you did mention that you all are working with drones, you all are working with UAVs. What are the other industries that you're catering to, and segments also?
Typically for these, but large cargo drones is something that's opening up right now. So these companies are exploring the opportunity at a government level with the military, where they can add value in terms of using these heavy cargo drones, which could say at least carry about 100 kilos of weight in hilly terrain regions. So instead of, let's say, a vehicle or a big Ashok Leyland truck, military truck carrying this across a valley, doing 30 kilometers in 2 hours just one way, only to carry about 100 kilos of, let's say, essential supplies. There are cargo drones that can do in, let's say, about 20 minutes one way. And they cut down the travel time, the complexity of going through the whole winding roads with debris falling from top. They just cut down all of this and just fly straight to the destination and drop off and come back. Sometimes, depending on how the flight path is mapped and engineered, they might have to swap batteries, but it's a straightforward operation, and there is no human involvement involved in the dangerous movement within mobility within the hilly regions, particularly in Himalayan road conditions, right? So this is one amazing use case that's opening up, and this is where there needs to be batteries with high dependability. Particularly, to give an example, let's say in a two-wheeler or three-wheeler, if a battery stops performing either through increased temperature or a cell imbalance or dozen other reasons, the worst that can happen is the vehicle will stall by the side of the road, or you just push it to the side of the road. But over here, that's not the case. If something fails, the flight is going to just drop down.
Safety is a much bigger concern here.
Yes, absolutely. So that is where Astra smart batteries kind of come into play, because we've tested it for like literally months, and customers have tested it for months, and they've given feedback where they can depend on this. So that is where our expertise comes in. So,
and what's been the most challenging point maybe of convincing a customer to use your product?
Yeah, so the challenging part is to, like I mentioned before, offering Astra utility, offering all the tech, though it is at the same price point as a Chinese battery or other counterpart in India. The hesitancy is there because there's a lot of integration that has to happen with their flight controls, which we have also done. But you need it. We are even willing to handhold companies for the let's say integration of 100 drones, so that their team also gets used to the whole integration process. There's the customer company needs to write few lines of codes. We have also made that available for easier integration. Nevertheless, that hesitancy is there. Second thing is that the complexity in the government regulations, which is kind of hindering the acceptance, because when a drone is type certified and let's say they have to bring a new battery on board, they have to go through the whole process again, which no company ideally will want to take it up. So we are having to wait until a new model is being designed, and battery is the heaviest component within a drone. So when somebody is designing a drone, they usually keep the heaviest part in mind first and design the drone around it, right? So it is for us to get into the earliest stage of the development cycle and then see through the end of it, and that typically takes 1 year. So when our investors or our stakeholders ask what's happening, it's a lengthy process, and on top of that, another 3 months to 6 months of certifications and all of that. So this is a major roadblock for us.
Got it.
So at getting a customer on board, sort of thing. So if you were to say the sales cycle for something normal, typical normal battery could be 3 to 6 months. Over here, it could go up to 12 months.
So
that's for a startup. To sit around waiting for that period of time.
That's a long time.
So this is where things could be made easier from the government side of things. So wherein DGCA could come into play, and and moreover, a lot of regulations are borrowed from the European standards, right? So we can probably set a new standard and make things easy for Indian companies to accept Indian-made batteries. That too, when we are offering so much of added features. Yeah. So that's a major roadblock for us.
Got it. You also answered my regulations question in there. So you're currently present in India. Are you also looking at?
We have got ourselves listed on a European B2B drone, platform. It's called as Beyond Sky, and it was started by an Indian who went abroad to study, and he has seen the whole market in Europe. But unfortunately, the acceptance is low because lot of drones are DJI drones.
Right.
And DJI kind of rules the market across the world. And a lot of companies who call themselves drone companies are actually providing a service using a DJI drone. So,
Right.
to tell you, I have a list of close to 750, 800 odd drone companies across the world, or drone services companies, I could say. And a majority of them are using DJI drones. So there's no way for us to penetrate that because DJI has its own smart battery. And when they are doing it at an industrialized scale,
Yeah.
where at a consumer level, at a B2C level, we are looking at B2B level. This is another thing, though we want to expand, but the whole Ukraine Russia war has given companies like us an opportunity. Though we'll be sanctioned in a lot of ways and a lot of government things that we have to look into, that's an opportunity for us because a lot of hobbyists are using drones at a warfare level. Ethics of it and everything, keeping all that aside, from a tech perspective, from a sales perspective, those things are a major revenue generating opportunities for us.
Right.
So, but regulations are there where we can't randomly export these batteries.
Sure.
But given the whole China plus one policy, informally from other countries, it's a good space. And given the whole geopolitical situation right now in the US and how the new administration might, kind of
Impact.
see.
Yeah.
Yesterday's article already says that the government might be considering sanctions around Chinese drone operations in the US. It already happened. A motor company and propeller companies were already kind of sanctioned in the US for having supplied to Iran and things like that. So that gives an opportunity for Indian companies like us to look at export opportunities. Particularly in Europe, it has not been that great.
Right.
But South America and Africa is a good opportunity for Indian companies.
Got it.
Yeah.
Got it.
We do have export ambitions because when we are competing at a price level to China, and that has majorly been possible thanks to government, where they have cut down the import duty on cells, and they have increased the import duty on wholly made battery packs.
Right.
And in spite of that, and even after that, we have been able to compete at a price level with Chinese batteries. So internationally as well, we have done some studies thanks to us being cohort of NSR cell at IIM Bangalore. It gave us, they kind of literally fed us with a lot more resources to enable this, kind of a survey.
Right.
And we can compete even in international markets with the pricing and literally undercut US made batteries and still have a very good margin. So US, South America and Africa are a very, very good market for us.
So switching gears to the infra side of things for a bit, what kind of facilities do you need or do you guys currently have for manufacturing and R&D and so on?
Yeah, we are based out of Pina industrial area, which is one of the oldest industrial areas in the country, and we have a 5,000 square feet facility as of now, which serves as our R&D and manufacturing space. And we are equipped to, cater to about 2,000 Astra units on a monthly basis. So our facility is kind of tuned towards that. Apart from having catering to certain R&D projects or a service project, which is completely one-off. So typically we take about one service project of sort on a quarterly basis, or it kind of ends up spilling into 4 months more than a quarter. So that is one. And in terms of manufacturing capability, we are good to do about 2,000 units a month. So that's the kind of facility what we have built. It's a 5,000 square feet facility as of now, but we are already on the lookout for a 25 to 30,000 square feet facility outside Bangalore as of now, which will serve base for the immersion cooling battery systems and also larger battery quantity for Astra itself.
Got it.
And the Bangalore facility will purely be for the engineering space.
Right. And obviously, we talked about this earlier. There are challenges in terms of supply chain, etc. How are you kind of streamlining this for yourselves?
Well, supply chain at this point, like I said, if Indian companies are going to do manufacture cells, that's the best thing. I mean, where we can procure from. Chips haven't been a concern post-COVID. Only during the COVID time when a lot of manufacturing lines were immediately shifted towards making chips that were needed for the medical industry and so on. Now those things have eased, and it's kind of a good move that India is setting up its own fab units, though it will take at least another 3 to 5 years before we see anything meaningful for our industry. Supply chain side, particularly on the major things like the cells and IC chips, we haven't faced any issues. But like I said, we can't rely too much in the long run on that, because one odd thing, one odd effect like COVID kind of can put that across haywire, right? So as of now, quite set, I would say. Nothing to be worried about as such.
All right.
Yeah. I mean, not just with regards to Hastin, but I believe that's across the industry.
Sure. Yeah. And we did have a guest earlier from Sarla. Adrian was here.
Yeah.
You just mentioned that you all are working together.
Yes.
Is there something you can tell us about that?
Well, one main thing I could tell is like wait for a month or two.
Okay.
Or probably by the time this is out, you will likely see a lot of movement in the public space around this.
Right.
Hopefully, viewers will definitely get to see the initial concept as what a eVTOL will look like, and what an Indian-made eVTOL will look like.
Yeah.
And the challenges are a lot, but from what I've heard and what we have been interacting, the government is working around coming up with a policy for eVTOL. So
yeah, we touched upon that
yes,
in the
right.
episode.
So the DGCA is already working on that. So that will give a lot of room for them as a company and us as, I wouldn't say ancillary units, but rather, it's a lot of interdependability is there, right?
Absolutely.
So it'll kind of give us a roadmap or a benchmark of sort as to what we have to be doing, where we have to be developing, and so on. It's a very nascent market. I don't see volumes coming in this market for at least another 5 years. But for us as a battery company, the only way we can stay relevant for a market like this is to be 2 to 3 years ahead of the game. Because, like I said, the regulations, right? So if I want to get a product certified, or rather if somebody like Sarla wants to get a product certified, let's say in 2028, I need to give the technology that will be relevant for 2028 in 2026.
Yeah.
Okay, and with the whole ecosystem probably that is in 2020. So that is a challenge. That is a challenge for us. But nevertheless, we have taken it up, and it's a very large battery system, something what would usually power a car of Tesla size or even bigger. So that is the kind of battery that we are talking that will fly, right? Along with 7 other people. So 6-7 other people. So this is quite a challenge for us. So people would say, okay, fine, what would move on the ground is the same what would fly up above, but that's definitely not the case. And we are being challenged in terms of how better we can make it. So in terms of the materials that we use for the whole mechanical aspects of it, in terms of the electronics and the safety aspects of it, everything has to be, let's say, 10 times better. And at the same time, a very crucial factor that we need to keep in mind is the weight. So in the whole aviation space, particularly with electric aviation space, it's all about energy density.
Yeah.
It's also the case with ground vehicles, but particularly more so with the electric aviation, or even for that matter in the unmanned aerial vehicle space. So the industry should be looking to move somewhere close to 400 plus to 450 watt per kg. That's the benchmark that we need to be targeting. Whereas now we are looking at targeting something like around, not with this, but in general as a whole, somewhere close to around 250 to 280. Right. That's where the whole space is. So we need to make the batteries robust. We need to make it, airworthy and not add weight. At the same time, there is no room for any failures, because they are, at the end of the day, the whole eVTOL space is targeted towards urban air mobility. So we can't have, like how we had electric two-wheeler fires up above in the air, because that's not a scenario we want. The onus on us is a lot as a battery company, battery engineering company. Like I said, we need to be thinking 2 to 3 years ahead in terms of how we engineer the batteries. That's a major challenge, because some of the cell technology which will be commercialized then is only on paper as of now.
Yeah.
So how do we use today's technology to be relevant 2 years from now is a major challenge that we are encountered with. And this is a starting point, and with further iterations, we will be able to increase the water per kg on a unit level and slowly work towards commercializing it and look at the economies of pricing and everything.
Sure. Sure.
It's a very challenging thing. So for us, the selling point rather is if we can do it for an electric VTOL, you can trust us on a drone that is probably carrying 20-30 kgs, because the battery weight over here itself is probably like 10x of that. So that's the challenge for us. That's also a marketing point for us, because hey, we have done an eVTOL, so trust us on your drones.
Sure.
That's the thing. So some experiments are going on in terms of batteries for space. That's also again a selling point for us, because it takes way more engineering effort to do that, and where you don't see volumes at all. You only see volumes for it being tested, for the airworthiness, for it, is it even good enough to go on the spacecraft. So if that can happen, I bet you can trust it for your agri operations, which is only about hovering around 20-30 feet up in the air and doing only operations in 3 to 4 acres of land. So
that makes sense.
Yeah. And so if we can challenge ourselves as a company to build batteries for those applications, I bet we can definitely cater to your applications in the low airspace sort of a thing. Yeah.
Right. So what is next in that case for Hastin? What's the future, next few years looking like? Any other innovations you're working on?
Chargers is something that's definitely coming up for electric unmanned, unmanned aerial vehicles, particularly for the agri drones, the surveillance drones. So we want to kind of connect the loop. As I have previously mentioned, we have battery management system and a software communication tool. And like I said, charging these batteries is also an issue. So there is a lot of fluctuation of current on the field, because at the end of the day, these batteries are being used on the field in a farm, where the dependability on the grid, because some of them even pull the line randomly. There are no proper stabilizers or anything kind of regulating the current flow. So when that happens, a lot of chargers just go poof. It's the same case with batteries. So we understood that, while we have kind of solved for the battery and the BMS and the software issue, there is a major problem in the charger itself. And another factor is that these chargers are still, I would say, 90 or 100% being imported.
Right.
So if we as a company can close the loop, because we understand batteries, we understand how they need to be charged, and we are also understanding what are the issues on the ground. It's a single window of sort for majority of the power, requirements.
Right.
At the same time, we have partnered with companies like Nautical Wings Aerospace, which is a Bangalore-based company which is developing propellers and electric motors. So this way, we are kind of closing the loop as to what is being imported from China, which is the motor, the ESC unit, and the propeller blades. So that is kind of the whole powertrain of a drone.
Right.
So it has already happened in the majorly happened in the EV, electric vehicle mobility, ground mobility space. But this is an opportunity where, demand for 15-20,000 drones are coming within the next 1 to 2 years. If I were to translate that in a unit level, X that into 6, literally 15,000 into 6 motors, 15,000 into 6 batteries. So it all runs up into 100,000, 120,000 units of requirement, all by one tender. And this is going to then overflow into private companies, just like how it has happened with the electric two-wheeler. So this is a big opportunity for Hastin, and kind of closing the loop on the charging side for Astra utility batteries, Astra smart batteries.
Got it. Exciting.
Yeah,
very exciting, and good luck to you guys.
Thank you very much.
And maybe to close out our wonderful conversation on a lighter note, you're obviously a young founder. How are you managing hectic founder life?
Well, my time is to just get out of the city and probably sit by a lake unmanned. I mean, sorry,
We can't get the
unmanned thing out
the
of my
jargon
brain.
out of
Yeah.
you.
Unnamed lake, which is not on the map, unnamed road, probably not thronged by the major crowd from the city. And I usually like to spend time at my farm
Okay.
with my friends who are there, usually like literally doing nothing, just staring at the sky, probably camping out at night.
Nice.
And fortunately, my team also enjoys the same. So apart from being away from work, we still end up carrying work talk over there even on the weekends. And that's how I spend my time. Otherwise, I just like to go riding here and there, mostly to spend time in the nature. Otherwise, it's always machines around us over
Sure.
here.
Yeah.
It could be laptops and systems for folks in the IT, but for us, it's one or the other buzzing machine. And that too, being in the battery space, it's some electrical machine that's always buzzing around you.
Yeah.
So just want to get away from that buzz.
From all the noise
yeah,
and buzz.
yeah. So yeah, I just take my dog and just go off into one of those places most of the times.
Amazing.
Yeah.
Awesome. So, Amit, I think this was such a great conversation. Thank you again for coming on. Super informative. I think very good for the listeners who want to learn about the battery space, even the drone space.
Yeah.
You gave a lot of information on that. So, thank you again. It was absolutely lovely.
Thank you for hosting, Hastin, and look forward to this and happy to interact with anybody if they have more questions on this.
Absolutely. We'll send them your way.
Yeah.
Thank you.
Thank you.
Thanks for tuning in today. See you next episode.